All right, let's look at number 7 here. F of x is 4/3 x cubed minus 2x squared minus 8x plus 6. Find the critical points of f. Remember, the critical points are, all that means is the points where the first derivative is 0. Okay? So I'm just going to figure out what f prime of x is and set it equal to 0. F prime of x in this case is just going to be, I'm just going to do the power rule on all these. So if I have 4/3 x cubed and I do the power rule, I'm just going to have 4/3 times 3, which is really just 4. I probably should have written that, but I didn't. So 4x squared minus 2 times 2 is 4x. Derivative of 8x is 8. Derivative of 6 is 0. So here's f prime of x, 4x squared minus 4x minus 8. That's going to be equal to 0. I'm going to set those equal and solve for x. So, look, you can do quadratic formula if you want. Completing the square, that'd be awful, on this problem at least. Or you could just factor. So I pulled a 4 out of everything. And then this factors down, in my opinion, fairly easily, right? So you get x squared minus x minus 2. So you're looking for two numbers that multiply to make -2, that add to make -1. So I thought -2 and +1 would work, right? Because -2 times +1 is -2. -2 plus 1 would be -1. Okay, so this breaks down into this. And then the only numbers for x that would make this whole thing equal 0 were if x was 2 or -1. So I put it like that. Okay? And when they ask for critical points, they just want the x value. It's kind of weird. I don't know why they don't want the y value with it too, but that's just the way that it's worked out over the years. Okay, find the absolute maximum and absolute minimum of f on the interval -3 to 3. Okay, so what we're going to do is the absolute maximum and minimum can only occur either at the endpoints, so maybe they're whatever f of -3 is, or f of 3, maybe those are the maxes or mins. The only other places the max or mins can occur are at the critical points. So what we're going to do is we're going to try f of -3, we're going to try f of 3, we're going to try f of -1, and we're going to try f of 2. Okay? I just wrote them in ascending order. So I started at the lowest one and then went up. Okay? I mean, whatever, you do it whatever you want. You just have to find all 4 of these. So f of -1, f of 2, f of -3, and f of 3. This is super important here. You have to do the original f, okay? Because the question is not asking when is the derivative at an absolute maximum or an absolute minimum. The question is, what are the maximum y values? The y values are given by this function right here. Okay, so what we have to do, this is kind of annoying, and when I gave this problem last year on the midterm, people freaked out because they didn't know how to multiply fractions. And I was like, well, sorry, that's something you should be able to do because it's calculus. And no, you don't need a calculator to do -3 times -3 times -3. You should know that. So anyway, f of -3, so I'm just going to take my original f of x up here, and then I'm just going to plug in -3 for the x values. Okay, so see how I've got 4/3 x cubed minus 2 x squared minus 8x plus 6. You can do these out. I used a calculator because I was a little lazy. So yes, I know I feel like a little bit of a hypocrite for, calling people out for being able to do this with a calculator, and I didn't. But, whatever. I can multiply the fractions. It's not that hard. Okay? So, and I'm sick. Leave me alone. F of -3 is going to give you a y value of -24. F of -1 is going to give you a y value of 32/3, which is what, like 10 and 2/3, so 10.66666 forever. Okay, f of 2 is going to give you -22/3. F of 3 is going to give you 0. That's surprising that comes out to 0 after all those fractions. So the question is, of all of these y values that I sort of dotted boxed, what is the highest and the lowest? So if you look through, there are a couple negative numbers. -24 is much more negative than -22/3. Okay, so that's going to be our absolute minimum. This will be our absolute maximum, 32/3. So our absolute max occurs at, and I'm going to list the actual point here. So -1 comma 32/3. So x was our -1 and y was 32/3. So I'm going to put the x, y pair there together. the minimum occurred at -3 for the x and -24 for the y. On what intervals is f increasing? Remember, f is increasing when the first derivative is greater than 0. So the easiest way, in my opinion, to do this is to scroll back up and figure out where the critical points are. So the critical points were at -1 and 2. You know that right when x is -1, f prime of x is 0. And right when x is 2, f prime of x is 0. Or in other words, at this point, the slope's 0. At this point, the slope's 0. What that means, and by the way, those are the only two places where the slope is 0. What that means is that to the left and to the right of these 2 points, the slope is not 0. So it's either going to be positive or negative. Okay? So this is where I just test points over in the interval. Like over on this interval, so left of -1, I got to try a point. I just chose -2. You could choose -1 billion if you wanted, or -7.4, or -pi. Okay? So f of -2, I just chose -2 because it's like right there. And it's relatively easy. Be very careful. F is increasing when f prime of x is greater than 0. Do not plug -2 into the original f of x function. That will only tell you a y value. It will not tell you whether or not the function is increasing or decreasing. We can't tell just from knowing a y value whether or not it's increasing or decreasing. Right? We need to know what f prime of x is. So you're going to take -2, which is in this interval over here, and plug it into your derivative function, your slope function. The result that you're going to get is 4. So what was our derivative function? It was right here. So here's f prime of x, okay? 4x squared minus 4x minus 8. I'm going to plug -2 into that function right there. So 4 times -2 squared minus 4 times -2 minus 8. When you do that, you get 16. 16 is a positive number. That means when we're going along the original f function, the slope at -2 is positive 16. So that's like really steep there. Okay? So I'm going to put a plus sign here because 16 is positive. Now, I'm going to try some number in between -1 and 2. For me, if I can choose 0, I like to do that because 0 makes things really easy. When you plug in 0 into this function, 4x squared just becomes 0 because that's 0. 4x becomes 0. So all you have is 0 minus 8. Okay? So 0 minus 8 is just -8. So f prime of 0 is going to give me a negative number. So I'm going to throw a negative in there. What is f prime of something over in this interval? Again, I could have chosen any number I wanted. You can't choose 2 because, right, f prime of 2 is going to give you 0. We already know that. So I just chose 3. You could choose 5 or 10 or, whatever. Just a sufficiently big number. Don't choose something that's going to make your life really difficult. Choose an easy number. For me, that was 3. Okay? So if you do 4 times 3 squared minus 4 times 3 minus 8, that overall at the end will give you 16. It's kind of funny that the derivative at -2 and the derivative at 3 are the same. So, all right, so that's positive. So what does this tell me? It tells me that f prime of x is positive on this interval, negative on this interval, and positive on this interval. So it's increasing where the pluses are, and it's decreasing where the minuses are. Okay? So it's increasing from -infinity to -1. I'm going to put a parenthesis here because it's not increasing at -1. What is the derivative at -1? We already figured out it's 0, okay? Because that's a critical point right there. So I'm going to do -infinity to -1, union 2 to infinity, and that gives me the plus areas there, okay? On what intervals is f decreasing? That's just the negative interval here. So that's going to run from -1 to 2. Again, parentheses, not brackets. It is not decreasing at -1 or positive 2, right? It's 0 here and it's 0 here. Everywhere in between, f prime of x is negative. So those are your answers for those.